Is visible? Anybody? Hello, I'm audible. Rahul. Hello.
Hello?
Yeah, I'm audible.
Yeah, you are audible, but your voice is very low.
Volume is there. Still, my voice is low. Hello. Hello, I'm audible.
Yeah, you are audible, sir.
Yeah, why nobody is responding? When I ask, you must respond because otherwise, sometimes there is a net problem or something may happen. Happening.
Yeah, your voice is audible, but in between there is like a voice is cut and your voice is very low, sir. You can increase your volume there.
Yeah, full 100% volume is there. That's why I'm asking
Okay, okay.
the issue. So if any time I'm unable to, uh, any issues are there, you let me know.
Sure, sir.
Yeah, I will start now. Okay, morning all of you. This subject is machine learning and applications. We'll see first all the unit syllabus, then we'll move on to unit 1, that is the introduction to machine learning. These are the uh, titles, and I will show you, and briefly I will explain the each unit as well. And in this title of this course is machine learning and applications. And this is myself, Balasubbareddy, and I will teach you for this course. And there is a different subjects, I mean different units in that unit 1, introduction to machine learning. Then unit 2, supervised learning, and unit 3, unsupervised learning, and unit 4 is dimensionality reduction techniques, and another unit is applications. So once if you thorough all these units, then we'll move on to mm, applications of a machine learning for electrical engineering. So in our case, I mentioned some of the applications as well. We'll see that applications in the fifth unit. Now we have some of the test books, not only restricted to this book. You can refer any of the test books. It is there in the library, and some of the soft copies of the books also I will share to you, and I will share this PPT as well after completion of every unit. Now there is a first 1997 machine learning is one book is there, Tom Mitchell, and then 2014 introduction to machine learning, and the year of 2018 M Gopal applied machine learning. Like that we have many other books as well. You will see that also. Then in unit one introduction, it is completely basics, introduction of machine learning, and then some definitions and types of learning. These all types will go through once in the brief introduction only. That is a supervised learning, unsupervised learning, semi-supervised learning, like that. We'll see that types of learning and data representation. So there is a different kind of data representations we'll discuss in that. Then hypothesis space, and then inductive bias, evaluation, training and test set, cross validation, and applications of machine learning. This is the unit one. It is completely, basics. Before going to some sort of algorithms and all, we should know some terminology, and then what are the evaluation methods, and then training data, test data, and cross validation. So some kind of brief introduction we must know. For that, this is the first unit. Then in the second unit, you can see supervised learning. As I said, in the types of learning, we have different types of learning. In that, major one is a supervised learning, and that itself is a one unit, classifications and regressions. So this supervised learning is related to classification problem as well as the regression problem. In that, linear regression, logistic regression will covered in that. And when it's come to the classifications, we have naive Bayes classifier and k nearest neighbor and decision tree, support vector machine. So all these kind we'll discuss in that part. Another one is overfitting. So what will happen overfitting and underfitting based on the data. If it overfit, what will happen, and underfitting, what is the issues, all these things we'll discuss. And advantages and disadvantages of supervised learning. And of course, we'll see some applications as well in supervised learning. Then we'll move on to unsupervised learning. So here, example of this is a clustering. Majorly, we'll consider as a clustering. So here introduction to clustering, types of clustering we'll discuss. In that majorly k-means clustering classifier, and then hierarchical clustering, Gaussian mixture model, and association. These are the some of the methods we'll discuss in the unsupervised learning, and advantages and disadvantages as well. And once if we covered the supervised and supervised, then we'll discuss what are the difference between supervised as well as the unsupervised algorithm. This is the third unit. And fourth unit, dimensionality reduction techniques, principal component analysis. This one method we'll use, dimensionality reduction. Another one is a latent Dirichlet allocation. So that is the another method, or we call it as a LDA. And then independent component analysis, and then introduction to deep learning. So here some techniques we'll discuss how the dimensionality reduction is going to take place. Apart from that, we'll see brief introduction about the deep learning as well. because the machine learning and deep learning also called as a deep neural network. It is preferably will use the neural networks strategy in this case. That's why this sometimes we call it as a deep learning or also called as a deep neural networks. And the last one is the applications of machine learning. Here is the load forecasting and energy market forecasting, fault identification, and the localization, and the renewable uncertainty estimation. So these are the some of the applications, but we no need to restrict only this. Once if you are familiar in these techniques, and we can apply the techniques to any other electrical applications as well, like optimization algorithm or economic load dispatch algorithm, like that many of our power quality improvement techniques. So anything, whatever, if you are familiar in these methods, we can easily adapt that for our electrical applications. Now we'll move on to unit one. So that is the syllabus for our 5 units, machine learning and applications. So in that first unit is introduction to machine learning, are also called as the basics of machine learning, and some definitions we'll see, and types of learning we'll discuss, and then data representation, structured data, unstructured data. There is a different kinds of data representation as well, because we are dealing with all the things are in the data only. So whatever data is available, we make use of the data, and then we can able to predict our new data comes, we can easily identify the solution. So that is the reason some data representation also we'll see. Then hypothesis space, and that area we have to identify by make use of techniques. So especially in this hypothesis space, whether that belongs to which classification, to identify the space line, all these things we have to represent in the hypothesis space. And inductive bias. So what will happen if it is a more bias, and what is the inductive bias, and then what are the evaluation strategies. So all these things we'll discuss in this area. And then training and test set, and some portion we need to train the model, and then some data we used for the test the model, like 80%, 20%, or 70% and 30%, like that. We divide the total data in terms of the for training purpose and for testing purpose. So when the model is ready, we need to check all these things and ensure that if new data comes, it is easy to identify what is your answer. It may be anything, classification side or regression side or anything, or if for unsupervised learning clustering also. For all the thing is we have to model the what you call it as machine learning model we have to establish. For that we required as a training data as well as the test, some set of data is required. And another one is a cross validation also, one of the to test the performance of that machine. Will go for a machine in the sense there is a model. So to test the performance of the model, you can use for cross validation as well. And finally, we'll discuss some of the applications of machine learning. Thus, as we can observe that it is nothing but no, we created that model by using the given data. Is going to learn the things. And as you are aware that artificial intelligence is a buzzword and enabling machines to think like humans. So we have to train such a way that the machines is able to think how the humans are going to act according to their requirements, based on the situation and the experience. So all these things will comes under artificial intelligence. That machine learning is subset of that, training a machine to get better at the task without explicit programming. And we'll move on to other slides and all, we can easily understand what is the major difference between expert system and then machine learning systems and all, or you can say that a conventional system and this machine learning in that training machines to get better at a task without writing a program. Normally, what we know so far, suppose computer is there, we have to write a program to get your task. Suppose A is equal to 2, B is equal to 3, and C is equal to A plus B. For that, normally you'll write a program to get your answer. C is equal to A plus B, that is equal. So, but here, what we are doing is we don't write any program. We will give the some test data. Suppose A is something, B is something, and C is equal to A plus B, like that. For example, 2 plus 3 is equal to 5, 1 plus 2 is equal to 3, like that. We are keep on giving the data to the model, and model is going train. And the later point of time, if I give A is equal to 2000, B is equal to some thousand, then what is your answer? So that automatically will calculate the sum. That is the thing will happen there in the machine. And deep learning, as I said, it is a very deeper mm, analysis with deep learning algorithm and network for and multi-layered networks we are using. So normally input layer and output layer, in between there is a hidden layers are there. In the machine learning and all, 2 to 5 hidden layers are there. If you go for deep learning, nearly or more than 150 hidden layers also. So that's why the computation time will be fast, or you can say that take more time to compute in the deep learning, but accuracy point of view, it is very accurate. So these are the, and we can notice this diagram, the data science also, it is the intersect of all these things. You can see that artificial intelligence, machine learning, deep learning, without data science, it is not possible. We required all the data. Now, as you know that computer science creates a intelligent machine that works, react like a human. So this is a model by training. We'll call it as a finally testing training is there. The model will be created that will act as a humans. Normally, the model or a machine is a AI-based machine, identify the patterns and insights more efficiently than humans can. Because why I call it as a more efficient than human, but some of the applications human cannot identify the solution or identify the result, but machine learning or a model can give the result, such cancer patients by seeing the MRI scan and all, the doctor may not identify clear cut of whether they have the patient has detected the cancer or not. But whereas normally machine learning image, lot of images, because the model is trained with many images, seeing that this image is attack the cancer, or other images maybe may not be the cancer, like that. We have the lot of huge data, train that and to test that. After that, at any point of time, if you submit that image, and it is automatically announced whether is having as a cancer or not. Such type of efficient models being to build here. And major part of artificial intelligence, machine learning is nothing but, as I shown you previously slide, it is the uh, majorly a subset of artificial intelligence. So that is subparts all this. And derives the mathematical relations between input feature and the output. Normally, we will write a mathematically, in normal case, I'm telling, a program we will write to calculate, suppose mathematically, A is there, B is there. If they ask C is equal to A plus B, and programmer has to write inside C is equal to A plus B. So like that, we need to write a program the conventionally. But machine learning model deals with the mathematical relationship between the input feature and the output feature. What we'll do is we are giving as input and also we are giving the output. So by seeing the input and output, they establish as a program, or you can say that mathematical relation. So like I said now, C is equal to something 2 plus 1, and we are giving 2 plus 1 is equal to 3, and 1 minus 1 is equal to 0, and like that 5 plus 10 is 15. If we give the data like that, then by seeing input side data and output side data, model has to develop his own equation. Let it be sum, let us assume that, and a plus b is equal to c. Like that, the model will create. Then at any point of time, if you give a value and b value, automatically that will give the result, because model is established with c is equal to a plus b. If you give a and b values directly, c will be generated. Then now the c will knows the values a and b is given directly, it will calculate c. But we are not writing the program, but automatically the system, by seeing the data, and it will be developed its own code or mathematical equations, input and output. The relation between input and output can be use the algorithm to predict the output for the future inputs. So what we are doing is here, like that we are giving 2 plus 3 is equal to 5, 5 plus 2 is equal to 7, like that. Then later point of time, if the input is suppose 10 plus 5, then automatically it will give as the result is 15. Like that, there is a relation between input and output. And model, intelligent model, this considered as a part of AI at the most basic level information, and solve problem on a computer, we need as algorithm. So general, we required as a algorithm to solve the problem. Sequence of instructions we have to write to transform the input into output. And that is what basic. And for example, one can divide as a algorithm for sorting. Input is set to the numbers and output of their ordered list. Now, sorting the program, if you want to write, if you give random numbers, then automatically program will give the results of sorting the numbers. For same task, there may be various algorithms, and may be instructed to finding the most efficient one, the least number of instructions or memory path. Because if you write the small program, you may be required as a, let us assume that 10 lines of code or something like that. But what is the intelligent will do, very minimum number of programming they have to write to get the answer. But whereas in machine learning, we no need to write any program. Based on their instructions of the input and output, it is going to be, that is our intention is the least number of instructions or memory, less memory. For some tasks, we do not have an algorithm. That is, like in Gmail and all, automatically some of the mails going to be stored in a spam. The spam emails and legitimate emails. So from the any mail comes, automatically that has to segregate. It will go to the spam, or it go to the mail inbox, like that. Mm, That is also one of the application in machine learning. The input email documents, that simplest case is a file of characters. So that is the thing. And we know that output should be yes or no, or in case, or otherwise you can say that whether the new mail comes, we have to detect the mail is spam related or not. So like that, this is what we are doing in the spam identification. And we do not know how to transform the input into the output, considered as a spam changes in times, and for dividing in the individual. So uh, from the individuals of mail, we have to identify whether spam or not, or like that. Another way, for sorting numbers, we already have as algorithm. But there are many applications for which we not have algorithm, but have example data. We are moving towards the machine learning algorithm, but lot of introduction I'm speaking. Still, some more, not only one class, we will consider two more classes also for introduction to, because it is a new for you and to understand what is the previous things is happening and what is the machine learning era. For that, many applications we have algorithm like a sorting numbers and all. But we do not have algorithm, but have some example data. Suppose you don't have algorithm, but you know the example data, sorting number. Suppose some input is given, some 5, 10, 20, 30, or 14 like that, and the output is sorting results may be available with you. Like that, a huge data with you, for different numbers, and then results of that is a sorting the number. So that way, we have the data available. And today we can store and process large amount of data as well as access it to remotely over a computer network, because now the everywhere computer is available. The huge amount of data is stored in a drives and all, or Excel sheets or data type, different kind of data sets are available. But anybody can use their the data availability data for their project or for their work, to identify or to train the model or to test the model and all. That is the computer can have huge amount of data, can access that. For example, supermarket chain, so hundreds of stores are available and selling their goods and millions of customers. But it is one of the example, we can say that one customer come to the shop, and we can easily, that machine learning model easily identify whether the customer is going to buy X product or not. That much precious data, because we trained a model such a way that once if we give the input data of this customer, whether his age or past data, all these things, the model is going to predict for the existing. I mean that customer is going to buy the product or not. And each transaction details, like date, customer identification code, goods budget, I mean what are the goods brought, and total amount spent, and so on. For each person, this the data, and what are the items he brought. So all these things available the data. The data may be typically gigabytes of data in every day, because not only the one shop, multiple shops are there, supermarkets, something like that. Huge population also there. Based on that, gigabytes of data is going to be generated in every day. The supermarket chain want to predict who will buy a product. So how, because of the past data of him, and monthly wise, yearly wise, and day wise, time wise, like that. So huge features are available in the data. By seeing that feature, system is going to be trained. Then if any customer comes, they will easily identify whether they are going to buy this product or not. So that is the thing. And then store data become useful only when they analyzed and turned into the information. So only the raw data available, but using the raw data we can able to analyze the data and convert into the data in the form of information, that can make sure of the example, to make predictions. So if you can able to analyze that, we can easily predict once new data comes. And who will buy this ice cream? Suppose normally by seeing person, we cannot say whether he will buy the ice cream or not. But by training the model based on his past data, based on his area or location, climate condition, and all these some basic information, the model is going to predict whether he is going to buy ice cream or not, watch his new movie or not, or visit the city or not, like that. If we knew, we would just write down the code without any analysis of the data. However, since we do not we can only collect the data and hope find the answer in the data. Now, by this information, we can easily understand that we don't want to write any piece of code. Only we make use of the past data and will train the model, and we can easily predict your answer. Customer behavior. So by seeing his face, we cannot identify his customer behavior, and we have to extract some of the features, and then the model is going to say his behavior is good or bad or something. Sensitivity analysis, sentimental analysis, all many things are there. It is not completely random. Generally we cannot say by seeing him is randomly his behavior. People do not go to supermarket and but buy things at random. Normally you will not go randomly and buy the thing, but we can able to understand the thing. When you buy as a beer, sometimes combination of the items also they can predict whether if we buy the beer, preferably they may buy the chips and all like that. But the ice cream is summer and some kind of atmospheric, or as I said in earlier, based on the information, certain patterns in the data I have to identify and segregate the data, and you can conclude your results based on that. So that is the way we can able to do the things. And we may not be able to identify the process completely, but we believe we can construct a good and useful approximations. So some kind of approximations also required in this time. Approximately may not explain everything, but may still be able to account for some part of the data. Identifying the complete process may not be possible, and detect certain patterns, and a machine learning will focus on the data. Understand the process, we can use these patterns to make predictions as well, assuming the future will not differ much from the past when sample data was collected, and the future predictions can be expected to be correct. So applications of machine learning methods are large data base is called as a data mining. Because normally huge data, as I said in the previous slide, a gigabyte of data also is generating in the every day. That is the large volume of raw material, means raw data extracted from mines. When the process leads to small amount of very pieces of material, and similarly there is a large amount of data processed to construct and simple model with a predictive accuracy. And some, just I'm giving you some sort of introduction for past nature. And now we'll start. Normally we can see that growing search for relevant information done manually, but machine learning not just for a database problem, it is also part of the artificial intelligence problem, changing the environment and ability to learn the things. Because it is by the model itself is trained without any guide, or nobody supervising, reinforcement learning and all. You have to do, if we achieve something we'll get the credit, if not punished, then will feedback is taken, and then again it will train like that. Reinforcement also is taking place. If the system learn and adapt such changes, the system design in not forces, and provide solution for all the possible situations, help us to find the solution to many problems. And vision recognition, like I said, it act as a in the robotic applications as well as vision, and then identification of fraud activity, something, many learning applications are there, and optimizing the performance criteria, data and past experience and present data. From that it is going to be adapted. We have a model with some parameters, and learning base to train the data, or past experience to optimize these parameters. And model may be predictive to make predictions in future, or describe gain knowledge from data, or both the parameter. And building mathematical models, because core task is making the inference from the sample. That is the thing. Now we can see human decision and one by one. These are some just introduction. Anyhow, that is not been in the syllabus. But only thing is whatever headings are there in the syllabus, that topics only you can read. But only apart from that, I'm adding the huge information to understand the real things. Now I move on to comparison between the human decision and then expert decision and all. Now we can see the human decision. Normally, doctors you can consider in the olden days. Now we have lot of test methods are there to identify whether dengue is there or not. But olden days are long back, by saying his symptoms only, the doctor can able to judge whether they have that did this so and so disease or not. In the same fashion, we can see that some of the input, if the patient comes to the doctor and if he explained something, doctor may ask the patient whether you have skin rashes or not, and his fever is there or not, headache and cold, cough, vomitings. So these are the features let's consider. By these features, the doctor can able to identify whether the patient is having dengue or not. But nowadays is already there the test, direct test they can. But how the human will decide? Now we can see one patient may come to the doctor and he's having as a skin rashes and is not having fever, and then but headache is there, and then cold and cough is there, are not there, and vomitings also there. So based on his the data, and let it be is a dengue. Consider is not a dengue because is not having fever, and then another cold and cough is not there. Might be is not having as a dengue. That is the first set of data. Now what I'm going to tell you, input data is this one. These are the input data, and then this is the output data. So based on the input data, doctor is decide the uh, output. But now the machine learning is different. Now we will give these two. Input data will give it to machine learning and output data also give it to machine learning. But the later point of time, one patient comes without any testing directly. Patient come, he may select his problems like skin rashes is having, and then cold and cough is also having, and vomitings is there, and then that machine model will decide he may having as a dengue like that. Similarly, other combination you can see skin rashes, fever, and then headache is there, and also vomitings is there. Then this may be dengue. And like that, these are the input data, and we are dividing the data, input data as well as the output data. So what is observation from this? Anybody can observe by knowing this data. If you have this data, not only this much, huge data is available. And if you pick up what are the things you have symptoms, then automatically the model is going to be decide whether dengue is you have dengue or not. But now you can see the doctor is deciding, the factor is a decided factor, and based on the inputs you will decide whether dengue is there or not. Like that are ones and twos, because machine learning or any general understanding, wherever ones are there and some cases, these are the cases, and this output also decide whether dengue or not. Now, similar fashion, another example you can see, the umpire can directly decide manually, human interruption by seeing this, and he will give the judgment, LBW or not. But nowadays we have as a software by seeing there all features. Now input feature is what, pitching in line or not, impact of this, and then height of the ball, and whether it is a right ball or a no ball, and then shot attempt or not, because this shot is attempted or not. And based on that, output will decide the umpire, and by considering many parameters, he will decide whether the batsman got out or not through LBW. Now this is the data, and each case by case, the umpire will decide whether he will out or not. But you can see here, some cases the output is the out, some other cases output will not, batsman is not out. So like that, we are deciding based on the input features. And similarly, in terms of numerical, either 1 and 0, also we can give it. And now this all about the human decision. Individual case by case, the umpire or maybe doctor is going to decide whether he is out or not in the case of cricket, or in the case of medical, the doctor will decide whether patient having dengue or not. This is the human decision. Now we'll move on to expert system. What expert system will do now? He will act as expert, or this guy is act as a computer or a model. This will not directly, human will not take as a decision. So what it will take as a decision, expert system will take as a decision. So here expert is a one model, let us assume that. So based on the mod input, you can see that in this case, these are the inputs. In that input, whether fever is there and rashes is there and cold is there or not, based on that he will decide, he will give the output. He means that is not manual doctor here, is a expert system. Like that, the what the system will do is, we are not writing here, you can see that what we will write is, in this case, program we are writing. Earlier, step by step you can come. The thing is, before expert system, human will take a decision. Now expert system, programmer will write a program saying the based on the input, and the program will decide whether he is having as a dengue or not. For that, this is the program. What program is writing? If high fever and cold is there, you can return is not a dengue. Or else high fever and then vomitings and not rashes, then return to no dengue. So like that, else high fever and then vomitings and then rashes, three are there, then you can return as a dengue. So who will do this? Some expert system or expert will write a program to get as a output. So what is doing, based on the knowledge, and then program is going to write, then the system will operate that inputs, and then it will check with the conditions, and it will decide whether is a dengue or not. And some limitations also there if you do that way, because huge number of data is there, writing a program also complicated. Again, some other application or similar application, slight change also there, we have to modify the program completely, and that is the problem, difficult to write the relations like that. Because earlier application, you can see there is only four or five, up to five are there in the input. If this is maybe 10 or 1,000, how can I combine these combinations? If this is there and this is not there, this may be there. Like that, if 10 or 20 parameters are there, writing such kind of relations to identify final answer, yes or no, or in that word, it is a difficult. That's the reason, like example, you can see that if you go to interview, whether they will select you or not. Manual interview if they conduct, and how the expert or interviewer will decide for you whether you will fit for the job or not. So in that case, what we are doing is here, lot of input parameters are there. Based on the input parameters, then you have to write a program. It is normal key. I'm expert system, I'm telling, not machine learning. You are writing the program. If his 10th class marks is equal to so and so, then here his CGPA is more than so and so, whether he published a publications or not, whether he is having as a projects or not, funding projects, he is how many awards he's having. So by combining many of the parameters, then if these things are satisfied, then you can say yes, or otherwise no. But many parameters, not only this small thing, is semester-wise marks, any achievements, co-curricular activities or extracurricular activities like that. If we keep on adding the input parameters are more and more, it is difficult to write a program to give final judgment of this problem. So like this, we can see here what we are writing is 10th class marks is this one, intermediate is this one, graduate yes or no, pass or fail or something, CGPA, and then how many projects he's having, and then how many publications, how many patents, so on so forth, and then finally how many awards he's having. These are all about the inputs. Now it has to decide whether he will get the job or not. That is what based on the program we can able to write the in the screen we can get the result whether he is approved or not. And now we'll move on to machine learning. So what machine learning will do, same thing is then instead of human writing the code, machine develop a code. This is the major difference between, you can see here. So we are writing a program to say yes or no. But same problem, what we'll do is we are giving as a training to this set of model, and then we'll give means. Based on this data, the model will generate one relation. So input relations x1, x2, x3, and so on. Then what is your output? Like that, it will create as a model, and that model you can see if CGPA and 12th class marks based on that. There is a two partitions are there, whether you are hire that employee or not. For that there is a line, clear cut line is there. So anybody is fit under this blue highlighter, it will be as a hiring, and upper side it is a don't hire. So that means the person to person, the base, if you simply enter the data, input data, automatically the model will return you the result stating that whether we have to hire the person or not hire the person. So in that partition you can see clear cut the points, the lies in the above side, the red color side don't hide, and points below the lower side it is going to be recruited. So that means the model has to develop his own code, or you can say in turn is the relation between input and output. Many number of inputs also there, using the data that will develop a equation or a model or a prediction or anything. If you give input, further input, then automatically it has to respond, stating that out. Then why machine learning is where we are using this kind of machine learning applications and all. Drive your car automatically, no driver is required. Simply you can, that some of the examples already there in Google and all. You can see that if a person in passenger seat, if we sit and he asks to give the command, go to so and so, that automatically car will navigate to there, and if anybody obstacles are there, it will slow down and all. It is model is going to be do that way. That is what you can see that drive your car, and machine can detect 50 eye diseases. Some of normal even doctor or some of the machines may not identify whether is having eye disease or not. But if you place same thing in the data, automatically even doctor may not identify, but model is going to identify stating that so and so is a disease for you. And machine can unlock your phone with your face. So just like a fingerprint provision is there. So our face, if we show to mobile, automatically mobile is going to be open. Like that of applications we required as a machine learning. Another one is definition fashion. You can see this machine learning enables to machine to automatically learn from data. So enable to machine to automatically learn from data, improve performance from expertise, improve the performance from experience, and the predict things without being explicitly programmed. This is sentence must remember, without being explicitly programmed. So by experience, by the data, it is going to be improve his performance, and we can show explicitly. And now we can see the comparison. Human, can I learn everything automatically from experience? Can I learn means by experience human can learn. Yes, machine also can learn from past data with the help of machine learning. So this is the small logic, and you can see how to train the system, or what is machine learning normally inbuilt. So this is again I said a set of artificial intelligence which provide machines the ability to learn automatically and improve from experience without being exactly programmed. Now we can see inputs are data. Some fruits, let us assume that they lot of they are quite bit similar. And now that is input data, and the algorithm it will develop by the system itself. Machine learning algorithm will by the system in a model the system, and it will give correctly whether it is a cherry or apple or orange. And how the system is going to train, I will explain here. Empower the computers to learn without being explicitly programmed, whatever one thing. Main focus is to develop computer program that can be themselves to grow. That is second point. Machine learning model or algorithm in learner patterns in data on the own, and then predict the similar pattern in future data. So what this will do is these algorithms patterns in a data, whatever existing data is there, that will take it as a pattern fashion, and then it will be moved. So this is the about small machine learning. Categories of books, we can rules regarding the constitutes and child books. We want to divide which book is related to child book, which book is related to parent book, something like that. And then field the knowledge patterns in these books are used to recognize future books is given in category. Now how to train a data, let assume that 3 year old kid is there. Now we have as apple, we are, you know, this now the later point of time the 3 year old kid is become as a model, nothing else. If I show something else, he will give the answer. But how he is trying to give the answer? By learning experience. Who will teach you that based on the type of algorithm, whether it is a supervised learning or unsupervised learning or reinforcement learning, like that, we are able to train. So first there is apple, and father will teach to his kid with saying that it is an apple. So he will think one by one by his learning experience. Then day one, this is called as an apple. He will teach to the kid. This is called apple. Then after that, in day two, also he will teach you by showing this apple, and teach to the kid and saying that this is called apple. Like that, by telling after one third day, you are showing as a mango, and you are telling to him this is not apple. We are not saying this is a mango. What you are teach to that guy is this is not an apple. So what earlier it was, we are showing to apple and telling to him it is a apple. But later that you are telling that other color, if similar way it is coming, then we can say that this is not apple. Then again fourth day you are showing real apple and showing that it is a apple. Now, similarly, machines will learn like the day five. What is this? Now, day one, day two, and all we are showing apple and saying that it is called as apple, and then another day you are showing mango and you are saying that it is not apple. And after some turn learning, we are going to test. What is testing? You are again showing the apple and ask him whether he will able to answer or not. Now you show to there and is saying that apple is not, I mean, a similar machine will learn what is this. If you showing the apple and ask him to tell the answer, then he may give the answer is it is a apple. Then it is a model is perfect. Like that, you will test. If you show to banana and you ask him what is this, like that, you have to train him and test the system. This is the indirect totally inside machine learning. We have a lot of data. It may be input data like what I shown you. Different types of fruits are there, and input is fruit name, and then output is input is no, image of fruit, and output you are telling it is a apple or banana or so on so forth. So that is the data is available, and then model, uh, ML model is there, and then method, or you can say that intelligent system will give the result. Now the data, we have a lot of household data. Let assume that let for example in this area you may have 3 bedroom, and the area is this one, apartment type, whether it is a what are the amenities we have. Then lot input data are giving and saying that output is this is the rent, 50,000 is the rent for that. Whether it is a individual house or apartment or a villa or something like that, we can give the data on related features and stating the output side, whether it is a we can say what you call it as a rent. And finally the point of time, you go to some other area like that, we have huge area data and so on. We can able to find some area. You go to Bangalore and you can give the data, and you can ask the system, they will give the rent. How this, you are training the data in Hyderabad, and if you go to give the data in Bangalore, it cannot be. That's the reason we need to train the data all the huge area. Suppose I want to find only in Hyderabad, you give the data in Hyderabad area, you train him and then give accurately it will get. And if you train the model in this area and you test the model in some other area, it will get efficiency will reduce. So that's the reason you can see that you are giving the data, and then based on the data method you are applying, whether regression or classification or something algorithm, and it will give the intelligence answer to you. And after some time you give this is the 2 bedroom, this house is 2 bedroom, and then area is so and so, and the location is so and so, and you are giving all the data. And if you enter, you ask the system, it will say what is the rent automatically. So that is the machine learning model. And we'll see the comparison, what I explained in theoretically, lot of slides in the introduction theoretical, but instead of that I'm showing you the just a black model, traditional programming approach, and then a machine learning approach. What traditional programming will do is, if you have as input or you give the input and write a program based on the input, then output is going to be decided. So what is you having input? A is equal to 2 you have, and B is equal to 4 you have. This is a input. Now you are writing a program, then something enter the input of A and enter the input of B, and then C is equal to, you are writing a program A plus B, then it will give the results of 6. This is what the traditional approach. Now we'll come to here model, a machine learning model. What that will do is, you are giving as input A is 2, B is 5, and also we are calculating C is equal to 7. Like that, you are forming as input data something like this, A, and then B, then C. You are keep on giving the data 2, 3, 4, 5, and then 1, 2, then answer you have to write here, and this is available with you. What you have? Data, input data is available. Respect to output is what? C. C is output also you known to you. Then by seeing this data, then the PC will write his own program. Okay, internally what is happening with the analogy of the data? Let it be final conclusion. Maybe there C is equal to A plus B. Let assume that. Like that, the program will build in the system. Then automatically, if we give some new data, if I enter A is equal to 2, B is equal to 4, automatically output will get it as a 6. Then how I can say automatically you are not writing any program, but you given as a data set here, and the model is going to develop his own algorithm, and you can say that model relevant equivalent mathematical model, and automatically you will substitute A plus B there and you'll get it as a C program. And now we'll see the difference between traditional programming and machine learning program. That's what I mentioned there. Traditional approach, input along with the logic in the form of a code. You have to write the input, and logic you have to write to get your output accordingly. On the other hand, machine learning approach, what is happening? Input and output are there. You have to available, takes an input and an output, and give some logic to work with new set of inputs. So new set of input in the sense, if you give something else and then to generate according to output. Machine learning algorithm are not dependent on the rules defined by human experts. It will not define by whatever you given the instruction, but it will learn by experience. That is what the major. So by experience model also going to be learned, then efficiency is going to improve. Process the data in raw form, and example emails, social media content, and web document, and still images, audio files, and video file. All these things are raw data available. How this data will get? It is generated by the internet, like Flipkart data, or Amazon data, or Google data, or like any Facebook, and then many social media data. Huge amount of data is available. You will get the raw data first. Then machine learning is more prediction oriented, and traditional approach is usually interpretation orientation. And traditional learning approach does suit well the environment and continuously changing also, that will learn that. But in contrast, class approach, machine learning approaches are generally too expensive in the environment. Just like spending a lot of computational power on learning quite a difficult model and highly dynamic model network environment, because that is small data. If you train and if you give, suppose one thing you can see, marks, if you and student wise marks, and then grade we are selecting, but some other missing data is there, and the system may not be properly trained. Whenever if you enter the new data, and the system is unable to give your accurate result if your data is not in proper. So that's what thing. Now as you know that machine learning voice assistants like Apple Siri, if you say that hi Siri, then if we comment navigate so and so, so automatically it will open the navigation, and it will show to you, like Amazon Alexa, and um, like that Google Translator and Gmail filter spam or not, self-driving cars recommended Apple. Some, if you open the Amazon and if you search some product, after some time it will show you the recommended applications or recommended products, or something like apps also. If you open in the stores, and if you see some of the relevant apps, later point of time it will, and fraud detection, the bank fraud detection, all these things. And if you want to see some of the things, we can able to identify mm how this is going to be. Some YouTube links are given, how series will work, or something Alexa will work, and how automatic car will work. That is available in YouTube as well. You can see that. And some brief introduction about deep learning also. That's what you can see in the machine learning. Input will be there and output will be there, and feature extraction and hidden layer. These things are layers are more and more. Deep word is a deep learning stands for the successive layers of representation. We may have the in detail of the layers, even 150 layers also you can use it to get accurate results. And this is the thing, learning is any process by which system improves performance from experience. And machine learning is a concern with computer programs that automatically improve their performance through experience. So like that, whatever it is developed is model, and by through experience, by learning defects, all these things, that itself is going to experience. And what is the learning? As I mentioned, the learning doesn't change the system, that enable the system to do same task more efficiently in the next time. So once that's what is learned by experience. Once if the model is not perform well, and by training more and more data by with the experience, and it will perform well. And the deep learning, most deep learning methods use neural network. That is what I already mentioned you. This is also called as a deep neural network. Also, we call it as a. And we can see that 150 hidden layers we can use it, whereas in machine learning only 2 to 3 hidden layers we can use it. Trained by using the large set of labeled data and neural network architecture that learns the features directly from the data without need of manual feature extraction. So this is the sum of the thing. Now we can see one small slide difference between deep learning and machine learning. So the input is given as a car input, and then as a classification is there, feature extraction is there, and the output it will decide whether the input image is a car or not a car. But deep learning also same, but the thing is these two will merge and will form as a feature extraction plus classification together will be is a one in the case of deep learning. And you simply give the input and it will give the output whether it is a car or a not a car. And like that, I will see some more introduction part in the next class, and then we'll move on to unit wise. Anyhow, we started the unit. For that only we required all these introduction, because first unit itself is a introduction to machine learning algorithm. So like that, we'll see some more features in the later point of time, and some introductions, and we'll go ahead. So this about today's class. If you have any clarification, you ask me. Otherwise, you can leave. If you have any doubt, you can ask me. Otherwise, I will end the meeting now.